Okay, so a functions question. Let's have a little go at this. What we got here, find the inverse. So I find it's helpful if I'm finding the inverse to write it as y equals 3x minus 5 over x plus 1. Now, it doesn't matter which order you do this in. Either rearrange it to make it x equals, putting it solely in terms of y and swap at the end, or swap now and rearrange it. But basically, we need to rearrange it to make it x equals. So we get xy plus y equals 3x minus 5. And this is actually trickier than it's given credit for in some ways, because we have to isolate x. Now that's going to happen by taking all the x's onto one side and factorizing out the x. Now if you imagine the 3x moving over, that's going to give me that. And I'm also going to dump the minus 5 minus y on this side. And then I've got x in terms of y. So I get minus 5 minus y over y minus 3. This tells me f to the minus 1, but I just have to swap the y's for x's at the end. So the inverse is, in fact, minus 5 minus x over x minus 3, which, yes, is the same as x plus 5, good for all you positive people, over 3 minus x. And that's the inverse. Okay, we've now got to find f of x, which sounds like quite good fun. So f of x is going to be where you plug f into f, which is kind of weird. So we're going to be doing 3 times 3x minus 5 over x plus 1 minus 5 over 3x minus 5 over x plus 1 plus 1. Now, I think the quickest way to get to the answer here would be to times the top and bottom of this horrible looking fraction within a fraction by x plus 1. That way we get rid of the fractions within fractions straight away. Let's multiply out the bracket at the top as well. So we get 9x minus 15 minus 5 times x plus 1 all over 3x minus 5 plus x plus 1. Simplify it, you're going to get 9x minus 5x, which is 4x. You're going to get minus 15 minus 5, which is minus 20, over 4x. Sorry, I feel like I've made a mistake. 4x minus 4. No, I think I'm okay, actually. And now if you divide top and bottom by 4, you've got x minus 5 over x minus 1. I got slightly put off there because I was imagining that a would certainly be a positive constant, but it's not, is it? A is minus 5. Slightly annoying when they write it as a plus on the top there. It almost puts you off. I'm just going to check I haven't made any sign errors. I don't think I have I? No, it doesn't look like it. I haven't miscopied the question. No, I think that's fine. Okay, part C, f of g of 2. Well, let's just plug 2 into g first. I prefer to do this almost piecemeal. So g of 2 is like 2 squared is 4, minus 6 is minus 2. Now I'm going to plug that into f. f of minus 2 is going to be minus 6 minus 5, which is minus 11, over minus 1. And so that is 11 as a final answer. Find the range of g. Be careful here. This is a quadratic, yeah? And it's a quadratic which goes through the origin and 3. Yeah, it goes like that. And you always want to draw it for range if you can. The reason why I say be careful is because they restricted the domain. So we're only actually going up. We don't want that little bit of the curve. Might as well scribble that out. We want it up to here, yeah? Now, when x is 5, I hope you can see that you're going to get 25 minus 15, so you're going to get y is 10. So that's going to be the maximum value of that curve for that given domain. But we also want to find the minimum. Now, one really cheeky way of finding the minimum could be just plugging in 1.5, because it's the beauty of quadratic curves is they're symmetrical around the minimum, and the minimum occurs at x is 1.5. The minimum value will actually be 1.5 squared, which is 2 1/4, minus 4.5, and 2 1/4 minus 4.5 is minus 2.25, and that will be the lowest value for the y coordinate down there. And so now I can state the range, because the range is going to be the y values which are permitted on that curve for those given x values. And as x is allowed to be equal to all those values, I think it's going to be like this. Minus 2.25 is less than or equal to y, which is less than or equal to 10. And that is the final part of the question. Okay, hope that made sense. Shall we whiz on to question 8? Might as well whiz on to question 8. Let's just get rid of this. Okay. Let me know in the comments if I make any mistakes. I'll be most amused. Okay, question 8. What have we got here? A spherical balloon. Oh, I quite enjoy these questions, actually, where you've got these rates of change. They're rates of change questions. They almost always involve using chain rule. Okay, we're told the volume of a spherical balloon is increasing at a constant rate. Now, I think actually the units in these questions actually tell you what you're dealing with. That is volume changing with respect to time, because it's centimeters cubed per second. Yeah, that must be dv by dt. Yeah, remember, these are all about rates of change, these questions, and if they've told you how much the volume is changing with respect to time, then they've told you dv by dt. Yeah, we've got to find the rate of change, the rate of increase of the radius of the balloon. So we've got to find dr by dt at the instant when the volume V equals 12,000 centimeters cubed. And somewhat bizarrely, they've assumed that you don't know the volume for a sphere. I disagree with that. I think they should just expect you to know the volume of a sphere. But there we go. Perhaps I'm reasonable. But okay, so what do we use here? Well, we're going to use a bit of chain rule. But first, let's just use that formula. We know that 12,000 equals 4/3 pi r cubed. Straight away, we can determine r from that, I believe. Yeah, we can know the current radius. That could be useful, actually. We just times both sides by 3/4. 3/4 of 12,000 is 9,000 pi r cubed. And so r is actually going to be the cube root of 9,000 over pi. But I'm actually thinking I've done something which is a bit of a waste of time there, because let's actually write out the chain rule which we use. We're looking for dr by dt. We've got dv by dt. Now, we could say dr by dt. If you're looking for that, let's try and use dv by dt, because we're going to have to use that at some point. Now, clearly, we'd like the tt to stay there, but we want to get rid of the dv. Yeah, so let's have a dv on the bottom and a dr on the top. That way, this definitely is true. I don't know if everybody can see how I've worked that out. I just kind of suss it out. You know, I think I'm looking for dr by dt. I've got dv by dt, so I write that down straight away. And then I think, what do I need to multiply this by to make that? And it must be dr by dv. Now, dr by dv, well, what is that? Well, we know v is 4/3 pi r cubed. But that means we know dv by dr. And dv by dr differentiates to 4 pi r squared. Yes, that is the surface area of a sphere. No, that isn't a coincidence. Anyway, let's carry on going. We now know dr by dv. That must be 1 over 4 pi r squared. And remember, we have actually determined the radius. So what we can do is dr by dt equals 250 times 1 over 4 pi, and then this r value, let's find out what it is. I'm going to have to reach for my calculator. Oh no, I'm going to have to get out of my chair. That's kind of annoying. Oh, stretching in the mornings, not advised. Okay, so what have we got here? 9,000 cube root. I'm going to use my full calculator display here as well. But what is that? 9,000 divided by pi, and then I'm doing that to the power of 1/3. Okay, I make that 14.2, roughly speaking, but actually use full calculator display when you do this. So we're going to do 14.2, but blah, 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 squared here. And let's see what that comes to. So I'm going to square that, multiply it by pi, multiply it by 4, reciprocate it, and then times it by 250. Okay, I'm making that, and I hope it's right. Feel free to leave a comment. I'm going to check it as well in a second, so I'll leave a comment myself. But 0.0986, which to two decimal places is, two significant figures is 0.099. Now, think about the units of your answer here. It's going to be centimetres per second, yeah? Because that is dr by dt, yeah? Okay, hope that made sense, and also hope it's right. Thank you for watching.